Good afternoon. Do get up and have coffee, that would be fine. What I would also ask you to do is, it's really a tough act to follow right now with Ian having presented the material that he did. But what is even tougher for me is to have to ask you now to move away from the specific topical area to solve a certain problem and ask you to look at a general, a higher level general structure of a course that would address certain things. And what I would also ask you to do is think about the 17 and a half and 18-year-old that we have to deal with in the process. As Eileen said, I am with Stevens Institute of Technology, and those of you who don't know Stevens, where we are right across the river from Manhattan. And coincidentally, Stevens is the place where ASME was founded back 127 years ago. And the first president of ASME was the chair of the mechanical engineering department at Stevens. And Stevens, up until 1958, only offered a degree in mechanical engineering and nothing else. So we have a long tradition, and at the same time we have a tradition where we pride ourselves for having had a broad engineering curriculum. To maintain a curriculum in mechanical engineering until 1958 and offer nothing else, that basically meant that you had to educate people in other areas besides mechanical engineering and have them focus through some electives in the discipline. So I want you to think about that as I go through some of the things that we have done and that I'm going to be talking about. About the world of mechanical engineering, I don't think I need to emphasize this anymore. I think that there has been a lot of discussion today about this, the need for considering the diverse areas that mechanical engineers engage themselves in, and as such then, the fit of diverse groups within our profession. I would like you to think about it in that way. Also, if you look at the samples that I have on the screen, you will notice that complex shapes, different areas, different perspectives, and all relate to product engineering, all relate to design at the end, and the role that many groups play in this. If I may mention, industry is very keen in attracting women in their design engineering functions. So that's another aspect that we kept in mind when we were talking about what to do in introducing engineering to our incoming students. So we wanted to address those issues through a course or through a class on Introduction to Engineering, and basically we thought that through that we would structure the course to expose students to products and services, particularly relevant to diverse student body, prepare our students for the curriculum, highlight the relevance of engineering science, we don't want to miss that, and we wanted to provide them choices, because when they get out, they would have many choices, even in terms of what careers to follow. Now, of course, there are still specific goals that you want to address in any offering, because credit hours are limited. By the way, Ian talked about limiting the number of hours to 40, which includes engagement as well as credits, looks at credits and our homework. In 1963, if you look at the catalog of Stevens in 1963, it actually lists there credit hours, contact hours, coursework hours allotted per course, and then total for the semester and total for the degree. We went with 50 if memory serves correctly, 52 as the number of hours of engagement of the student, as opposed to 40. But anyway, back to what I was about to talk. These are the areas that what you're seeing there, these are the areas that, or the focal, or the specific goals that we wanted to make sure that we address in addition to what I mentioned in the previous slide. Creative thinking, introduction of computer applications for solving problems, because we are in this world where IT is basically in our lives. Develop technical report writing, team project planning, all of the items that we discussed earlier today. Now, how do we handle all of this? First of all, I should say that all of our students in the freshman and sophomore year take the same classes. So then we had to deal with not only mechanical engineering students, but also students in engineering of all the other disciplines. And we also have what we call design spine throughout our curriculum, which means that we have a design course in every semester throughout the 8 semesters. So in order for us to do what I just highlighted, we would have to do it through these 3 different offerings that we have, engineering graphics being one, everybody takes that. Engineering design one, everybody takes that, and engineering experiences. And I am going to highlight all of those as I move along. Total number of credits for all of these. In engineering graphics, obviously, traditional offerings together with something else. So what we want to set out to do is broaden the scope of the engineering graphics course to expose students to a range of graphical communication tools. And the reason for it is basically because we also have students have to be able to address also complex contemporary shapes, in addition to the fact that we wanted to show relevance to non-mechanical engineering students of the subject matter to their discipline. And then, as a last element, we wanted to make sure that we encourage them or have a way of encouraging them to apply whatever they learned in the graphics class to something through a project. The reason for it is because, as you probably know, it's a pretty dull subject, and students really hate it. So we were basically looking to see, and it's not that we didn't have a graphics course, so this is an improvement, or we thought it would be an improvement. I've listed here all the topics that we're covering. This will be available. Amy will have all of the material, so I may have to skip or go through this rather quickly. So our objectives, basically, we wanted to provide an opportunity to our students to apply and enhance their graphics and modeling skills, and then to develop communication skills so that through the project it would not be necessarily an individual, could be a team effort. The project would run over a period of 7 weeks. So first 7 weeks is instruction, and the other 7 weeks would be that. And what I've listed here, I know the type is small. I've listed what they had to do, but I give you pictorially what the outcome would be. They had to pick, they would pick their own topic in terms of a project. So the selection of a real product, this individual, this female, decided to do the type of clock that you would see in swimming pools. She's a swimmer, so she's an athlete, so this is what she decided to do. And selection was the first one. Initial sketching is something that we require. Part drawings, something that we require. Assembly drawing, something that she did with this. Bill of materials, again, they are being instructed to develop this. And then a final report at the end. And by the way, if you're reading what I have there, it says there is a pledge that is being outlined there. Stevens has the honor system, which basically means that the students, if they receive help from anybody, they must mention who helped them.